68.3% of flood damage reports occur outside FEMA's high-risk flood zones. Less than 4% of American homeowners carry flood insurance. The standard 100-year flood carries a 26% probability over a 30-year mortgage. The map is wrong. The pricing is wrong. The protection gap is widening. This paper makes one claim. The era of underwriting flood risk on 1980s paper maps and zip code averages is over. The future of flood underwriting is pixel-level deterministic modeling, fusing hyperlocal computer vision, synthetic aperture radar, and physics-informed neural networks. Flood stops being an unpredictable catastrophe. It becomes a priced, mitigated, calculable asset class. 3 structural failures break legacy underwriting. First, FEMA's special flood hazard areas are static. 75% of these maps are older than 5 years. 11% date back to the 1970s and 80s. Second, the pluvial blind spot. FEMA models fluvial and coastal surge. It does not model rainfall-driven urban flash floods, which is why nearly 68% of damage occurs outside high-risk zones. Third, the cliff effect. A property 1 foot inside the zone is mandated to insure. The neighbor 1 foot outside is rated low risk despite identical hydrology. Coarse pricing creates adverse selection. Cross-subsidies destabilize the risk pool. Deep AI replaces zip code aggregation with a 3-layer architecture. Layer 1, computer vision for structural truth. The most critical variable in flood loss is the first floor elevation, the vertical distance from grade to the lowest habitable floor. Raising that elevation by 1 foot above the 100-year flood elevation reduces average annual loss by approximately 90%. Convolutional networks based on YOLO and mask RCNN segment the front door, foundation, and stairs from street view imagery. With the camera fixed at 2.5 meters and standard riser heights at 7 inches, 6 visible steps yields a 42-inch elevation. Layer 2, synthetic aperture radar. Sentinel-1 and commercial constellations like ISI transmit microwave pulses that penetrate cloud and rain. Calm water reflects specularly, appearing dark. In urban scenes, the double bounce against vertical walls generates bright pixels. Deep convolutional despeckling and UNet change detection isolate newly inundated pixels against a dry conditions reference. Layer 3, the simulation layer. Traditional hydrodynamics solving the St. Venant equations take hours to model a single catchment. Pure data-driven networks hallucinate physically impossible water. Physics-informed neural networks solve both. The total loss combines a data term and a physics term. The network is penalized when its output violates conservation of mass or momentum. The result is a fast, generalizable surrogate. HydroGraphNet routes water through a graph of streets, pipes, and rivers in milliseconds. The benchmarks are unambiguous. Lowest floor elevation estimation from street view achieves average errors as low as 0.218 meters, approximately 8.5 inches. Fusing radar with optical imagery for flood classification exceeds 92% accuracy in complex urban landscapes. ISI constellations deliver near real-time flood depth and extent within 24 hours of an event's peak. The economic case is sharper still. The U.S. homeowners insurance combined ratio averaged 101.5% in recent years and peaked at 110.5% in 2023. The average flood claim is roughly $34,000. A 1-foot increase in first floor elevation cuts average annual loss by 90%. Insurers that read the receptor, not the zone, can identify the elevated home in a floodplain that competitors reject and accurately price the basement-equipped home in a Zone X that competitors undercharge. This is what cream skimming looks like in a pixel-level world. The asymmetry is permanent. For the carrier, the argument is governance. State departments of insurance increasingly demand explainability. Black box deep learning is a liability. Physics-informed networks grounded in St. Venant are interpretable glass box AI. A premium increase is defensible as a hydraulic prediction, not an opaque correlation. The renewal cycle becomes obsolete. Risk models become living. Subsidence detected by radar updates adjacent property scores dynamically. Parametric triggers pay automatically when radar confirms 30 centimeters of inundation, eliminate the adjustment process, and deliver immediate liquidity. The carrier transforms from a payer of claims to a partner in resilience. This is what we believe. The transition to deep AI in flood risk underwriting, a technical and economic paradigm shift. Read the 15-page brief in approximately 22 minutes.